Assalamu alaikum and welcome. I'm your host Rashid Al-Hawli and this is the Muslims in Tech podcast. Today I've got special guest Zaher Joukhadar, who is a research data specialist currently working at the Chancellery of the University of Melbourne. He's part of the Melbourne Data Analytics Platform, MDAP, an interdisciplinary team working to uplift digital research capabilities at the university. Brother Zaher, thank you for joining us on the podcast.
Thank you for having me.
Well, let's start simple and let's ease our way in. So tell us, where did it all start for you?
So I'm originally from Syria and I immigrated to Melbourne in 2013.
Nice.
I did my undergrad at the University of Aleppo in Syria. Computer science, we call it informatics engineering over there.
Okay.
And I specialized in AI and natural language processing in Syria. And then I came in 2013 to do my master's here in computing at the University of Melbourne. And then after I finished my master's, I got a job position at the university at the end of 2013.
Nice.
And I've been working at the university as a researcher / research data specialist, data scientist since 2013.
So you've been at the university since 2013?
Yes, I've been working at the university for 10 years now.
Oh, wow. There you go.
Yeah.
Interesting with regards to your bio. I think I had a look at your LinkedIn profile and I saw that you received some scholarship from La Trobe in 2007 or something?
Correct, yeah. So when I was a third-year student at the University of Aleppo in Syria, I was ranked the top student there. And at that time, there was like a twin city agreement between Melbourne and Aleppo.
Yes.
And they introduced one-off scholarship, an exchange program between the University of Aleppo and La Trobe University in 2007. So I came to Australia first time in 2007. I did 1 year and part of my undergraduate degree at the La Trobe University.
Yep.
And then went back to Syria in 2008.
Yep.
And then after that, I spent some time in Syria. I graduated in Syria, and then I taught at the University of Aleppo for some time.
Mm-hmm.
And then I got another scholarship to go and do another year in Stockholm, Sweden, the Royal Institute of Technology.
Nice, yeah.
And then I did 1 year there, and then I came back again to Syria, and then at the end of 2012, I left Syria to Turkey, and then from Turkey I came also on another scholarship to do my master's at the University of Melbourne.
Okay, wow. See, there's a bit to unpack there. So I think let's start first with when you were teaching at the University of Aleppo.
Correct.
What were you teaching?
So I was teaching subjects like data mining, natural language processing, and fundamentals of artificial intelligence.
All right. So for the average person that doesn't really care for the inside out of, all the data mining and wrangling and, natural language processing and all the models and stuff that's involved in it, can you give us like maybe a brief layman's summary of what all of that is? Especially, let's start with data mining.
Yeah, so data mining is a field that's closely related to artificial intelligence. So the aim of data mining is when we get this big data sets, like everything now is stored in data sets.
Mm-hmm.
And how do we make sense of that data? How do you derive some insights for the data when the data it is big? So the data mining is the field that is very also related to machine learning, trying to extract knowledge from data. So when you have a really big data set, it's no use if you don't know what's happening in that data. And you need a specialized algorithm in order to extract some meaningful insights from very large data sets that will help you make decisions of organization or business that you're dealing with. Yeah.
Okay. And when you say specialized algorithms, what are some of the algorithms people use?
So before machine learning, I would say, or before AI, people would use statistics. So, for example, if you got a data set of products selling large data sets of sales of product, then you would do simple statistic. What's the most location that was products sold at, for example.
Yeah.
So specialized algorithm, when I say that, it's the machine learning, which machine learning is actually glorified statistics.
Yep.
So it has its root in statistics, but it's a quite advanced statistic. When I say advanced statistic in machine learning, so the introduction of the neural network, like perceptrons, I would say, is the first neural network that was introduced in the 60s.
All right, before we go further, because I like where this is going.
Cool.
Explain to us briefly what a neural network is.
So neural network, artificial neural network, I would say, is an attempt to model the neuron in the human brain.
Nice.
So there was this scientist from, I think, the 60s. They were impressed, of course, by the human brain. And there was always attempt to try and make artificial brain, right? And the attempt was started by modeling this neuron. So by studying how the neurons in the human brain works, how can we model that? How can we convert that to mathematics? So, and this is where the first neural network appeared. It was very simple neural network. Perceptron, it borrowed concepts from mathematics to try and simulate a neuron activated, for example. So they built this neural network that is able to learn. When I say it's able to learn, it means that it's able to find mathematical representation of what it's trying to learn. So it's trying to model how the neuron in the human brain works in mathematics.
Yep.
And this was the start of artificial intelligence.
And this was in the 60s?
Yes.
Okay. Wow. So this has been a long time coming, pretty much.
Yeah. So it was in the 60s. They came up with the perceptrons, and then nobody really. The development of artificial intelligence was extremely slow.
Yep.
Because the model that came up is a very simple model that is one neuron, meaning one representation of neuron, and one neuron is not able to learn anything. So if you've got one neuron, then you, for example, if you've got that neuron would have, let's say, 1,000 parameters. What I mean 1,000 parameters is that when you want to train that neuron, you need to do 1,000 mathematical operations.
Yep.
And 1,000 was quite a large number for the computers that were
At that time.
out of that time. So it was quite very slow progress until the computers are now very powerful.
Yeah.
Like the iPhone and then the computers and now the GPUs.
Yes.
And then once this hardware infrastructure really progressed very fast, then the scientists said, okay, now we can have 2 neurons, for example. We can have 3 neurons. Now we can have multi-layered neuron where the number of operations and parameters jumps from 1,000 operations to billions at the moment. And now when you have these all neurons lined up and connected, then you're able to model more complex mathematical equations. Therefore, you're also able to model more complex patterns and for example, images or videos or text as well. So it's more about the progress in the hardware that really pushed the theory part.
Yeah, there's quite a bit there, especially in terms of, because I've been listening a little bit to the rise of NVIDIA of late, especially when it comes to GPUs and how they pretty much donned the name GPU themselves, so they took it for themselves, much to the disgust of Intel. But what happened with them, from my understanding, is that they initially were for gamers.
Correct.
And essentially, I think some kid who was a gamer, his father was like a scientist or was working on some quantum computing project, and essentially he told his father, look, why don't you try out these GPUs? They'll, improve your runtime, especially, when you're training models. Anyone that's trained the model before knows it can be anything from, an instant training, which is, very small. But for a model that is to do anything of significance, it can be hours and days on end even. So in that time, he managed to go out and buy a few GPUs, and it drastically reduced his training runtime pretty much for his scientific computing. And that was actually the kind of watershed moment for NVIDIA in terms of getting into scientific computing and what they call high performance computing now.
Yes, correct. So I think what we have now in the AI revolution, we owe it much to the gamers.
Yeah.
Because the GPUs, when they were started creating the GPUs, they were created specifically for games.
Mm-hmm.
And games are computationally heavy. What I mean is that when you try to make a 3D game, you need a processor that's specialized to process these visuals. For example, you've got, one of the most difficult thing to do in 3D is lighting. For example, how the lights were gonna hit some surface and how would it look like. All of this involves calculations, a lot of calculation, metrics calculations, I would say. And in for them to be able to do that, they had to design this specialized processors. So, CPUs existed before, but CPUs is not optimized for matrix multiplications. Okay. Therefore, they created these GPUs, very designed specifically to do this matrix multiplications in order to be able to render these really great visuals for the games. And that matrix, it turns out, the matrix manipulations or multiplications is the essence of training a neural network. So when you have these multiple neurons, you're doing a lot of matrix multiplications.
Yep.
When you do it on the CPU, it's going to be slow because the architecture of the CPU is not optimized to do matrix multiplication. It's optimized to do a single number multiplication, for example. And I believe without gaming, I don't think we would have this AI revolution, because also gaming is an industry, is a big in terms of money,
yes,
which really justified, for example, spending money on research to make these GPUs.
So who was spending money on research in gaming? Was it NVIDIA? Or was
Yes,
it
definitely. It's mostly NVIDIA, I think, because they are gaming oriented, and you can't really spend money on R&D unless you have some kind of revenue stream that is supporting that. And gaming was really the backbone. Like the games, they make games, they sell it, people buy it, and there's a big industry bringing money to NVIDIA. And then, there's a big industry bringing money to NVIDIA, and then this allowed them to make these GPUs even better and better. And when the AI scientists picked up on these GPUs, then NVIDIA also spent even more research to make a version of these GPUs that's specialized for training of AI models, which is really more optimized to train these large models, and not more at the graphical bit, but also there's also GPUs that are graphical bit as well.
I've purposely not dug into large language models yet, because I know it's a big topic in and of itself.
Yeah,
we will get to it, but I do want to go back to the representation of learning. The initial model we spoke about that came out in the 60s, where there was a single neuron, and then the understanding of learning by the researchers at the time was, you mentioned there was a mathematical interpretation.
Yeah.
Why I want to go back to that is because there's quite a bit of controversy now around defining learning and what common sense is for a machine, for example, especially for general artificial intelligence.
Yeah.
So can you tell us a bit more about how the researchers at the time defined learning and how that definition has evolved over time?
Yes, I think there is learning and there's intelligence.
Yeah.
So there are many attempts by scientists to define intelligence, and all these definitions, I think it tries to model the human intelligence.
Okay.
And it's all like we are human. We always want to replicate ourselves, to create something that replaces us, right? So the learning bit, I think when they started is simple. Like we want an image and we want a model that tells us whether there is a dog or a cat in an image, right?
Yep.
And what they wanted to do is that we can do like at the end, the computer is only doing calculations, right, and equations, and they wanted to find a way to represent what makes a picture has a dog or a cat in a mathematical way, right?
Is that right from the very beginning, or is that more recent?
So the image, I'm giving an example for someone to understand. It's the image, of course, is more recent.
Yeah.
But for the beginning, it was trying to like making this Boolean gates, like and or X or.
Yep.
Like if I think the first was trying to learn to train perceptron to be able to understand what's the output of the AND operation.
And this perceptron is a representation of a neuron.
Correct. Yes, it's a very simplified representation of a human neuron. A human neuron is a lot more complex, but it's very basic representation. Just a dot product with some weights on it.
Yep.
So the concept of learning in AI is trying to find this mathematical representation that really is behind this natural phenomena that we are seeing. So subhanallah, because Rabbil Alameen, in my opinion, mathematics is behind everything. So, and I don't think a human really invented mathematics. They discovered it.
Yes.
I think because Allah subhanahu wa ta'ala created created mathematics, which is the underlying laws of everything that's living, for example. So when you are able to create a neural network that's able to tell you whether there's a dog and cat, that means this neural network has found the mathematical representation that is beyond what visually is a cat, what visually is a dog, for example, and that's part of that's really part of AI. Is can we call this mathematical representation, we call it the latent space or the embedding representation. So it's trying to find this. So it is a representation. It's a mathematical space. So if you think about mathematical space, you can think first about 2D space, like X and Y, right? Yeah.
Mm.
You've got one dot, and there's X and there's Y, and then you've got a 3D, which we live in, and there's 4D, for example, if you add time. Okay. Now, in mathematics, we study even 5D, 6D, 7D, or even 1000Ds, for example. We are, as a human, we can't really comprehend more than 3 or 4, for example. So, but in mathematics, you can write equation to describe that. So, when a neural network is built, we consider every parameter or every weight on it, or every, let's say, every calculation is a dimension.
Yep.
So if you got a neural network that, for example, has 1,000 dimensions, so when you get more dimensions, you're able to represent more complex phenomena in mathematics, right?
Yep.
So like a ball, like a circle in a 2D is a ball in 3D. So ball is more complex. A sphere is more complex than a circle, right?
Yes.
If you think about this, then if you go up to thousands or 100, there's some kind of representation that tells us this image has a dog, and this image has a cat. So the representation of what a dog visually appears in an image, and this is really the back end of AI.
Okay. So essentially, AI is about extending dimensions to the point where this artificial intelligence, quote unquote, can understand what it's seeing. So to speak.
Correct. Yes. it's extending dimension to find a combination of numbers
Yep.
that allows you to represent complex objects or complex phenomena.
So when you say allows you, you mean, is that like the AI giving us that result back? Is that what that is?
So it's allowed the AI to, for example, if you think about an image of a dog, for example, or a cat, it's a collection of pixels, right?
Yes.
And every pixel has 3 values, red, green, and blue.
Yep.
Right? So if you pass this collection of pixels into an AI model,
Yeah.
so the AI models need to find a set of numbers that when it does calculate with this set of pixels values, it will tell you it's a dog.
Okay.
That set of numbers, we call it the embedding space or the latent space that we find.
Is that where the parameters sit?
That's what the parameters.
There we go.
So when you hear about a model that has, for example, 10 million parameters or 1,000 billion parameters, it means this model is modeling things in a billion dimensions. And when you have a billion dimensions, then you're able to model very complex, like a human language. Human language. So the more dimensions or the more parameters you have, the more complex phenomena that you are able to build a mathematical model that understand it.
Okay, and is that why, for example, a lot of people are looking to AI for things like drug discovery because of the amount of simulation you can do beyond what was previously capable?
Correct. Yeah. So yeah, because AI allows you to model very complex phenomena, and the role of AI scientists or data scientists is to find a way how to build a model that will find these complex dimensions correctly to be able to. And it's not like, for example, this is how training works. So you really need a huge data set because one single image of a dog, you'll not be able from one single image find this set of parameters that are really able to tell you every dog.
Yeah.
So you have to, the network has to see lots of variation of dogs, and it finds the optimal set of parameters. Then this optimal set of parameters really understand what a dog is, for example. And then whenever you send it an image to the dog, it will tell you, yeah, that's a dog. Even though the new image that you're sending it hasn't seen it before, but it has learned the representation of a dog.
Okay. Yeah, interesting. You touched on something, actually, you probably didn't even notice it. This was something we used to discuss quite a bit. So I always thought, and my understanding was, that AI was pretty much the marketing term, and then, machine learning engineer or data scientist or whatever was the, how can we say, the correct term. So explain to us the difference between a data scientist, a data specialist, artificial intelligence specialist, so to speak, engineer. Explain to us that distinction.
Yeah, I think there is no well-defined distinction.
Yeah.
It's all blended together.
Yeah.
But usually we say AI is the big umbrella. Like artificial intelligence is the big umbrella, and under it there are people try to separate topics like machine learning, data mining, natural language processing. But in my opinion, it doesn't matter because there is lots of overlap between this stuff.
Yeah,
and
it really.
So I'm talking about in theory, for example, in academia. But when you're talking about job position or description, like data scientist versus data engineering versus AI specialist, it's also very very hard to define. Depends on the company and the business they're trying to. But usually when we say data scientist, is more involved in the algorithmic part.
So modeling or
the modeling, the trying to come up with a new architecture of neural network to train a problem. And the data engineer, I think it's more involved at the DevOps part, the infrastructure part.
Yeah, they only call them the plumbers.
Oh yeah, the IT, the IT plumbers. But I think it's not an easy task anyhow.
No.
Yeah, it's extremely hard. It's trying to to make these pipelines work, and that's the data engineering.
Yep.
And there's a computer vision specialist. There's there's really not a dictionary of well-defined descriptions. I think what matters at the end is if you're starting your career in this area, it's that you do what you like to do or what you love to do, and don't really. It doesn't matter the title that you're attached to, but yeah, I have been attached to like many different titles like software engineering, research fellow, research data specialist, and as academic specialist, for example.
Yeah.
So, but I've been doing like similar things. So it doesn't matter the titles. I don't think they matter. They matter a lot.
Yeah. And one interesting thing I found was that I think Airbnb put out a really good article about some of those distinctions, and you highlighted some of it. But I think the three main titles they were looking at were data analyst, data engineer, and data scientist. Because in their case, I think he's a partner now at YC. He actually was the first growth hire, or like he was kind of their growth hacker. That's where growth hacking came from. His name was Gustav Ahlström or something like that at Airbnb. He was one of the first few people there, and he was actually a data scientist. So he used data to help Airbnb grow, especially at the early stages. So they had a pretty good culture when it came to data, and they had an understanding of data, which you find a lot of companies unfortunately don't have.
Correct.
So they were able to segment from 2018. I remember this. They were able to segment data specialization into analyst, engineer, and scientist. So engineer and scientist, I think you've explained, quite well, especially according to their definitions, because that's how they did it. And then analysts, of course, will, a lot of the time they'll do like querying. Depending on what tools you use, there's pandas processing as well if you're into Python, and R language as well. So they then become more customer facing, if you want to put it that way. So they'll present back to the executives and the board, and they normally have more of a communication role as well.
Correct.
So give life to the data.
And I think this is when you see a company that really well defines these positions, is a good sign of the maturity of the company. That means they know what they need, and they know what they're doing. And you're right, the analyst is more like creating reports and charts and diagrams to present to the end user, or and the engineering is sitting in the background, and the scientist is trying to come up with new things. The data scientist,
the one thing I found when we were at uni was that we did quite a bit of modeling. We did one subject called data wrangling, which I found, incredibly difficult.
Yes.
But then what you find is that most of the time in the real world, it's all about cleaning data, which is pretty much data wrangling. So I think 60 to 80% of the time.
Definitely. Yes. I would say yes. 80 to 90% of the time.
There you go.
I think it's so data wrangling is a process of getting this raw data. So data is always messy. So no one really cares about. So when a company, they're trying to collect data, or they have a data repository where their staff are inputting stuff, no one cares of the quality. They don't have a quality check of when the data entry is. So and also these companies, they don't really realize the benefit of AI until later stage. So they don't have in mind policies of when this data is collected or entering the system, how can we quality check it? They don't. So you, as a data scientist, you come at a point where the data has already existed without any goal of how it did exist. So the data is always messy. And in order for you to get this data into modeling, there's a lot of work. And I would say 80% or maybe 90% of work happens there. You need to understand the data. You need to sit with the stakeholders, understand how they collected the data, and understand the domain of the business you're dealing with. And then curating this data set or into a format that's ready for feeding into an AI model. That's a long process, and it's like a lot of people don't like to do it, but I think if you're good at it, it's a really good career because not a lot of people like to do it.
And like the thing is, data is increasingly messy, and it's like from a number of sources too. And then you got to be able to integrate it to make it useful, and cleaning it, as you said, is 80-90% of the work when it comes to creating models. But also, like, I remember we were implementing machine learning even within cleaning, like pre-processing.
Definitely. Yes. Because this data is already big, and to be able to clean it and find out what's happening there, you need AI as well. So, and especially when you've got multiple data sets coming from different kind of sources, then you have to harmonize them. And that's a very difficult task. And also, if they're coming from multiple modality, if you have a text data set, you've got a video data set, you've got an image data set, you need some. And if you want to do some modeling on all of the three modalities, you need to link them together. So data linkage, data wrangling, data cleaning, it's all part of the job. And in Australia, there's like when it comes, for example, to medical data, like to hospitals and GPs, it's terrible here in Australia. Like there's no linkage system that links your data at a GP, for example, with the data at the hospital. So there's no each other.
Yes.
So there are attempts at the moment to create linkaging infrastructure, like the Biograde Institute, but still in the early stages. So these data are really sparse and random. And they're not connected, and that really makes it difficult to make AI models on medical data, which I think is unfortunate, because if you're able to collect all these data, they'll be able to make modeling, for example, to predict cancer or to predict some kind of disease. But the data in Australia for medical area, it's not very well curated yet. In the US is a lot better. I've been involved in one of the projects with trying to link this data between hospitals and the GPUs, and also the GPU notes as well, like when they take notes.
Yes.
Yeah, trying to process these notes is, I mean, when you, like doctors, when they write, they write with a paper and pen. You can't read it.
No.
And even when you give them a keyboard, you can't read it, because when they write things, they write the first 2-3 letters of a word and they don't continue. I mean, because they're very busy. So, I mean, AI really can help. For example, in these areas is correct the GPU notes and make it more understandable, stuff like that.
And does that involve creating, like working with, say, the healthcare sector to create like a training data set that you can then use to, say, to test other data? And then
So I think with the medical data, there's multi-layer issues, because there's obviously the terms of access the data, and this is also like personal sensitive information. This information first, before anybody can access it, it needs to be anonymized. For example, any reference to people or location and to do that, you need an AI as well. So, but I mean, the medical area it's difficult in every country because of
out of privacy.
Out of privacy and for the right reason, I think.
Of course.
But eventually AI will get there. It's not there yet, but I think AI can really help when it gets into this medical large data in for example, predicting patterns. One of the project that I we tried and worked on is trying from nodes of a GPU or patterns of
A
patients.
GP or a GP?
So GP, sorry. For predicting patterns in patients that might indicate they would develop a cancer. Like, for example, from their attendance at the GP, whatever they prescribed, whatever notes they have. So I think there's a lot of room for AI, but still very limited in the medical field.
Okay. And your current work now, is it mostly in the medical field?
No, so I work at the university. So we work in a central team of data scientists. We aim to help researchers at the university in digital capabilities.
Yes, that's right.
So what we do is we work on a basis of every 6 months we collaborate with researchers around the universities on their research projects. So I worked on medical, I work in fine arts, I worked in lots of, like, we jump a lot of, but what really underlies our work is these researchers at the university, especially from disciplines that are not very tech savvy, for example, medicine, dentistry, or even fine arts, they always need help in their research in the digital or the technical part. This is where we collaborate with them. So we help them. We upskill them. We teach them how to use, for example, these technical tools. Like if you want to, do some visualization in Python, for example. We can tell them how to do it. Or sometimes these medical researchers will come with data sets that are messy. They want us to clean it and also do modeling on it. So we were trying to upskill the researchers at the university in this area, because AI and big data analytics is really getting into every field in the world, and the university is really trying to be up front of this stuff, and that's why they formed this Melbourne Data Analytics platform as part of the Central Chancellery, is to help all the researchers and faculties get into this digital wave. And
if you ask me, it makes a lot of sense, especially when it comes to research, because a lot of researchers have access to a lot of data in general. So like using things like AI to speed up that process, it helps. I just wanted to highlight the fine arts example. Where did AI come into fine arts?
Yes. So as I said, we are like in the team, we put an expression of interest for researchers. So we work only within the University of Melbourne.
Okay.
So we serve the University of Melbourne faculties.
Yep.
Okay. We put an expression of interest where researchers would apply for our time.
Okay.
So they present their ideas and research projects, and then they would apply. And then once they apply, we select, for example, 10 or 15 projects to work with.
Okay.
So we get a lot of applications. One of the projects that I worked on with an artist from the fine art is called The Heart. With The Heart. The Heart, yes. Which is in Melbourne Connect. So Melbourne Connect is a new building here at the University of Melbourne at the intersection of Grattan and Swanston Street. So in Melbourne Connect, when you enter this Melbourne Connect building, is a really very, very advanced building. I think the smartest building in Melbourne. There's the main foyer. They wanted us to make a digital art piece there. So me and an artist from VCA applied with an idea. So the idea is to create a physical heart of the building.
Okay.
A 10 meters heart, but the heart is made of LEDs in the shape of a heart. So
nice.
We can go to Melbourne Connect to show it. And then for me, my part is to take census data from the building.
Yep.
There is about 4,000 sensors in Melbourne Connect, and use AI to convert this raw data into some visualization that will run inside this 3D display of the heart.
Oh, okay.
So the idea, and also derive a heart rate. So the idea is that when the building is working hard, for example, there's a conference, there's lots of people, more than usual, then, for example, you get a CO2 levels higher than the normal.
So that's one of the things you track, CO2 levels?
Melbourne Connect tracks everything. So they track number of people, they track CO2 levels, they track the elevators. I mean, there's sensors everywhere. Of course, there's no camera, so it's all like anomalous information that you can't really track people. Like you just data.
Yep.
So we get this data. So the idea is that, for example, when there's something happening, then the heart would beat faster, meaning that the building is working harder, for example, and some kind of visualization that happens. This is a fine art, meaning like contemporary art piece where AI is playing a role.
Yeah, it's interesting seeing AI kind of manifest in some kind of physical form, because like you often think about bunch of people in a bunker, way at it, dark rooms and alley, there's neon lights and so on.
So interdisciplinary is the new thing. Like it's interdisciplinary is really making when, for example, when we work with a doctor, they, for example, used to use Excel, for example. Maybe we can make some tips that makes their work 10 times faster, and it's easier for us, for example. So when there is an interdisciplinary collaboration, I think the impact is always amplified 10 times, because when you bring these people together, they make life easier.
Yeah, and the thing is with doctors, like I know for a fact, I think 2/3 of their time is spent on administration stuff.
Correct, yes.
Lots of paperwork. Yes. So a lot of that can be automated.
Definitely, yes.
Yeah, and give them more time to spend with patients.
Yeah.
On that note, we speak a lot about big data today and the breakthroughs in big data. But I remember, and I've heard quite a bit about this in terms of the future being small data, because ultimately, not everyone has access to the infrastructure to build LLMs. So that's why large language models. So that's why, for example, you've got folks from Facebook, and then you've got OpenAI, ChatGPT, and then, only a few candidates that can actually create those kind of models. Whereas in terms of the future of artificial intelligence and how it's used by everyday people, Andrew Ng, I hope I said that right, but he created like the pretty much most popular course on machine learning and artificial intelligence. He was like I think research scientist at Baidu and Google Brain.
Correct.
Yep. So he spoke about, I remember listening to him speak about small data and how it comes from what you were explaining pretty much, working in interdisciplinary teams and having domain experts on board, so that you don't really need as much data to get the same amount of work done. So maybe touch a little bit on that.
Yeah, so I think there's multiple sides of this.
Yes.
So I think there's the data, but also there's a model, and there's the training.
Okay.
So these large language models that you've heard of, for like ChatGPT or others, they're very big models. When I talk about parameters, for example, like I think ChatGPT has about 600 billion models. To be able to run and train this model, you need infrastructure, and the infrastructure they use costs millions of dollars.
Yeah.
So, sorry. Yeah. So the research direction at the moment is, for example, the research direction is to find out how we can make these models smaller. Because in the average scientist and even researchers, you won't have access to infrastructure to train large language models, right? So the idea is that, and this is where quite a recent field in artificial intelligence started, is called the knowledge distillation or model compression. Is that the idea is that these large models, like, so the assumption or the hypothesis is that we don't need 600 billion parameters. So we call these models, maybe they're fat, and we need to trim this fat. Yeah. So the idea is that how can we find the smaller models that really can do as good as the large one? And these smaller models, for example, they might run on your MacBook. They might run on your phone. The other direction that really pushing into this one is privacy and computing at the edge. What I mean computing at the edge is that there's gonna be a really need to do all the AI on your device, especially for sensitive data. For example, I don't like the iPhone, for example, sending my biometrics to their server to unlock my phone. And they claim they don't do it. They do it all on the phone. But in the future, to be able to do this large language model, big models on the phone, we do need to compress them. Yep. We do need to distill the knowledge from this large model into smaller ones. And the future is AI at the edge, because people are more aware about privacy. People are more aware about what's happening in this big organization. There's always going to be a push. Oh, I don't want to send my data to these big centers, making use of my data, benefiting from it, or even leaking it for some organizations. So this is where the first bit is, that we need to make these large models smaller.
Okay.
And this is the research area in AI, is that can we make small models perform as good as the big ones? That's what calls knowledge.
It's like an active research area.
Correct. It's called like knowledge distillation or model compression.
Yep.
So the idea is that you get this large model already trained, it's super good, and you get the smaller model. What you do is you try to train the smaller model to predict the output of the bigger model. And if it's able to predict every output, then it's kind of like distilling the knowledge and compressing it. So it's always like, the idea is that in mathematics, these models are too big.
Yeah,
that's what we think, are really too big. And because we don't understand how they work, definitely we don't understand why we need 600 billions, for example, parameters. The idea is too big. There is always a smaller representation of this embedding space that will work. But maybe to find this smaller one, we need more resources. We need more training on the bigger infrastructure. But once you find it, it's a small model. You get it and put it on the edge. You put it on the camera that has processing. You put it on the phone. You'll be able to do inference there. So it's all gonna have on the edge. And that's like, I think ChatGPT or like Meta or Facebook, they introduced Llama 2 or Llama 1. That people were able to distill it into a model that will run. So there's difference between training a model or running a model, right? Training a model is building it and having it able to predict the stuff you want to predict. But running a model, you've got a pre-trained model, and you run it. So when you go to ChatGPT and you put in a prompt, this is inference. It's just taking your prompt and passing it through the model and give you the answer. Mm-hmm. Even this inference, when you have 600 billion parameters, what we don't know what the ChatGPT is. That takes you can't really run it on your laptop. You have to have an infrastructure on Azure or AWS. Yeah. So this process is what's important. The inference one is when you have a smaller parameters, then you can take that model, put it in your MacBook or your phone, and then you do the inference on or run the model on your phone. This is what they did with the Llama. It's not as smart as the bigger one, but it's smart enough, I guess. And that's the trend. I think that's the direction that the research is pushing towards.
But for me, it sounds like that's pretty stagnant, though. So, like, once the model is done, then that's it. Like, you just this model is complete. It's not really being fine tuned anymore.
Yes.
So
the idea is to fine tune it on the cloud.
Yeah.
But when you are using it, you use it on the edge. So what matters for me, like my biometrics, if I have, let's say my prompts that I'm talking to ChatGPT.
Yeah.
I want my prompts all to stay on my phone. I don't want my prompts to go into the ChatGPT server. They look at it and they give me the answer. Yeah. I don't mind if they fine tune the model and give me a new model that I can put on my phone and then use it. Okay. So what important is the usage of the model that I am personally doing. I want it to be only me that have access to it. Yep. I have control of, okay, maybe I want to clear my prompts, or I don't want I no longer want my face biometrics being used. Then I can delete it from, I have control because I have my phone. Yeah. But if it's in the server, if it's on the internet, there's no way to remove it. Yeah. And that's the case been since the beginning of AI and the digital revolution. But the trend should be, everything needs to be, you do need to have control on your data. Yeah. You need to have the right to say, I want to delete my digital print, but you don't have it now. You can't really delete your digital print.
Yeah, it's very difficult. That and that's an ongoing topic now. Like, I think it's an ongoing debate amongst citizens, amongst tech companies, amongst politicians, because the citizens care about it. I think we see a whole suite of privacy laws coming out as well, and that's why you saw Sam Altman fly all around the world, I guess, to see. So he saw it as like a focused product tour, but also because there were a lot of concerns. I think places like Italy banned ChatGPT, and I'm sure there were others, I think, that were thinking of following suit. So to reassure people of their data and their data privacy, this conversation is not going to end anytime soon.
Yeah, and I think we're a bit too late on this conversation, because I think this conversation should have happened in 2000 or 2001 or 2, before Facebook. So, like, I think Facebook started 2004 maybe, or something like that. But they did horrible things at the beginning. They collected lots of data, and it's only recently they started to talk about privacy and these issues. But after what? Like, they've already built the business on our data, on our how we behave, how we interact. So all data is already there. All that, even Google is the same. Yep. Maybe Apple is a little bit better because their business model is not focused on data, is focused on hardware. iPhone. So I'm not sure if I can believe these companies, but I think Apple maybe is the best in terms of
the string of Apple. I think they recently got hit with a fine for using user data for advertising.
Yes,
Carolina.
So they're all the same.
So there's because they do sell advertising on the App Store. So
you're right.
Promote apps. Yeah. So ultimately,
they track people.
Yeah.
So track people use it.
So they may not allow outside people to use the data, but they still use it internally. It's a similar thing with Amazon and third-party merchants. Where they.
I think Facebook and Google are the worst in this regard. Like, in terms of, their business model is all really built on your data. You are the product. Yeah, exactly. Facebook is free, Google is free, but you are the product.
Yeah, 100%. That's what they all say.
Yeah.
So we've kind of spoken a little bit about the compressing. Actually, I read an interesting research paper recently. It was like 14 lines of Python code, and they just used gzip, like the compression software, and they were able to get similar results to. What was the name? Like 6 of the 7 top LLMs available in the market.
Yeah.
And I think that one was from scratch. I don't think that was distilled.
Yeah. That's. There's really promising direction in this area of trying to come up with smaller models that does as good as the larger ones. And that should be the trend. I think that's the right way to go about it. But it, also, like, if we talk about data, for example, that's where it starts. Like,
Yeah.
there's a really big ethical questions in there, especially for ChatGPT and OpenAI, because they've used data from the internet, and they haven't really told anybody what the data they used. There is a lot of, I think, data they have used they shouldn't have used. For example, copyrighted data, or like an image or a photograph that's copyrighted. Maybe they used it because they've got this DALL-E model where you put a prompt and it gives you an image, right?
Yeah.
And as people have tested, there's like an artist, I think, she put her name and it get an image really matching her style. And her work is all copyrighted. So and she put it on the internet, yes, but it says that's only my work. You shouldn't use it. But then she said, well, how is DALL-E is able to learn my style if they haven't trained it? They definitely train it, and I think she's suing OpenAI on that regard. So yes, having access to data is the key thing, and having a legal access to data is even the key part. And OpenAI, I don't think they're doing right in that area. So that's data. You need big data to do this big model, and then the distillation comes around, and then you've got this smaller model there.
Yeah, I just think it's interesting because I think if I'm OpenAI and I'm Sam Altman or the team that started OpenAI, I'm thinking Google got away with it. They were able to pretty much crawl the whole web and without any qualms.
Definitely.
And then why can't we do the same? Because Google didn't ask anyone for permission when they started crawling websites.
Yeah, and they will get away with it as well. I think these organizations they have become too big for someone to stop them. Bigger than countries, bigger than governments, I think.
Trillions of dollars.
And like Microsoft or maybe Apple is 1 trillion.
Couple trillion, yeah.
Or maybe 1.2 or something. And also Microsoft. They're bigger than countries. It's going to be very difficult for the legal system or a country to fight. But they should. I mean, they're starting, like in Europe now, they've got this, that was like 5 years ago where they really forced websites to ask you whether you want the cookies saved or not. They get this message, and that was because of Europe. The European Union introduced a law that forces every website to get a permission from the user before they can save cookies. Cookies like it, or access their cookies, because they get information about their usage of other websites they can use and their product and stuff like that. Yeah.
But what do you say though to the argument that now, because I think people kind of realize the capabilities of AI, governments are essentially, by putting on these barriers, are making it hard for people, for challengers to compete. Because ultimately, like, the incumbents have all the power right now. They have access to the models. I think Sam Altman said on Twitter they pay $3 million a day just in infrastructure bills.
Definitely,
So no startup can compete with that. So what do you say to the argument that this legislation is good, it's important, especially protecting privacy, but some governments are almost in bed with these companies, protecting their reign on AI, and going along with the doomsday theory of if we leave AI into the AI research space, if we let it flourish, then we're all going to pretty much end up with a robot apocalypse.
Yes, this is really interesting because I watched the Congress hearing of Sam OpenAI. So I think the Congress in the US, they don't know what they're gonna do with this new AI revolution, and they invited Sam to ask him what should we do.
No conflict of interest.
No conflict of interest at all. And I remember Sam told them something around, we we do need to, like, I mean, he proposed a solution to them to legalize or to regulate AI that really makes it even harder for smaller company to penetrate the market, right? So I think he said they're working on it, and then maybe we can let anyone work in the AI, making these language models based on their cognitive ability. Like they're trying to create some measure to measure how smart is a model is.
So he's
trying to say, okay, maybe we can have a smart level. If the company is building models that's not very smart, they can build it without license.
Yeah.
But if they want to build a model that's smart at above a level, they need a license. And this smart above a level is this company, OpenAI, Microsoft, and that's why. I mean, then like you can't really. It's already hard to penetrate the market. But I think interestingly, I think what Facebook did is good.
Yeah.
For the first time when they open source their Llama.
Yeah.
And this really opened up the open source community to work on that. I think the only area that they will be able to push away from this dominance by big companies is the open source community.
Yeah.
And open source community wouldn't really have access to big data infrastructure to train ChatGPT.
Yep.
But Facebook trained Llama.
Yep.
And they open sourced it. And then that's a foundation model that open source community is starting to build up on, which is I think a good thing. There is some kind of
of course.
Starting.
And the other thing is that there are open source large language models like Stability AI, for example, out of the UK.
Yes, that's another one. Yeah, Stability AI is an interesting one. But Stability AI is more in the image and video area, and Llama is the text one.
Yep.
Yes. You're right. I mean, there are some models. I think it's better than the OpenAI model, definitely.
Yeah, look, and I think they asked him because he used to be big on open source, Sam Altman. I think now because of the position he's in, it kind of makes sense that he's into enterprise and protecting IP and stuff, even though other people's IP isn't protected from him.
Yeah, I mean, OpenAI started as non-profit.
Yeah, of course.
And they changed to for-profit.
I think that was
partially.
That was the legalities in terms of getting investors on board.
Yes, but I'm not sure what the structure that. But I mean, it started as open AI. It has open in its word, but it's not open. No, I mean, ChatGPT. They proposed. They didn't even publish a paper of how they built ChatGPT. They also didn't publish a paper of how they build GPT-4, for example. So they used to really publish papers before, but when they reach ChatGPT, they say, "Oh, that's too good to publish," and they didn't publish it because they didn't want people to compete. And from ChatGPT until now, they haven't published anything about the inner working of how they build this algorithm and the models.
Yeah.
There are some like previous papers that speaks to the algorithms, but the exact details of how GPT-4 is ChatGPT, the free version, which is GPT 3.5.
Yep.
But there's a GPT-4, which you pay for it, which is a lot smarter than GPT 3.5, significantly smarter. But we don't know how they did GPT-4 at all. Like they didn't tell us why. I mean, how come they were able to make it even smarter?
Yeah.
And if you compare all these language models that are open source one and GPT-4 really exceed significantly in terms of solving mathematics, cognitive tests, and being able to understand the physical environment.
Yep.
There's some kind of magic happening in GPT-4 compared to the other ones, but we don't know.
It's a black box, big black box.
It is.
The only thing though is a lot of developers have been complaining about GPT-4 of late. It's not, and there are actually studies done about it.
Yes,
that
it's coming, it's becoming dumber, right?
Essentially,
Yeah. Yeah, right. So I read this paper that you're mentioning, and I think part of it, I think one very difficult thing in this large language model is how to evaluate it.
Okay.
So how can you develop metrics that when you do a next iteration and try to improve it, how can you tell you're not doing worse?
Yeah.
It's very hard, right? I think that's part of the problem because OpenAI haven't figured out a way to evaluate this large language models, and that's why they don't know when they make the next iteration whether it's going to be dumber or less intelligent than the previous one and less accurate. And that's where the researchers really tested, and they found that the GPT-4 June version is less intelligent than the March version.
Okay.
And I think part of the other one is trying to prevent bad usage. For example, like OpenAI put for example, when GPT started, when you ask her how do I break it to a bank, for example, it would answer you. But now there's controls put in place. Oh, I cannot answer these bad questions, for example.
Yep.
And they think these kind of controls made this cheap models less intelligent and limited their ability. But they're necessary, definitely.
Cool.
But finding the right balance between this and this is not an easy, and not even OpenAI apparently has figured out yet.
I think that'll be something that's ongoing.
Definitely, yeah.
So I want to go back to something we were talking about in terms of the edge. So having AI on the edge.
Yeah.
So I actually previously worked at a company that was doing like IoT software. So I think that's it's very interesting you mentioned that, because like being able to run AI models on things like, little devices, let's say it's within a car gauge, or let's say it's even in space, because ultimately in space, like, you can't ship the code to space. You've got to put it onto some kind of a drive, and then some astronaut has to take it with them and put it on the satellite or whatever it is, they're running the AI on. So maybe highlight a little bit of maybe some of those use cases and how, AI on the edge will help push that forward.
Definitely. I think the space industry is the biggest beneficiary from this.
Yeah.
So when you send a satellite to the space, first of all, the connection bandwidth that you have with the satellite is extremely limited.
Yeah.
So these satellites, you can't really talk to them until you have a line of sight to them.
Yes.
For example, if we send a satellite here above Australia, and it will circulate around the world, or orbit around the world, you only have the opportunity to talk to it when it's above Australia, for example.
Okay.
And that really makes the communication bandwidth extremely limited. For example, another example, like it could be like in terms of hundreds of kilobytes per day that you're able to communicate with the satellite. So you definitely need some kind of AI that runs on the satellite itself.
So,
and also autonomously as well. So that's really an area of research, is trying to make these models smaller is very important. Makes the space applications a lot more amplified. For example, AI in space is not very active at the moment because of the limitation of communication. You can't really send a model that's like 300 megabytes back into Azure and then try an inference and then come back into the satellite. So the edge is one part. Also the surveillance as well, the cameras is another part. Is if you want to do the processing on the camera itself, there is a need for that. And the phones as well, which is the most important one, because if you want privacy, you need all the processing to be done on the phone, offline. I don't want data to go to the cloud. But now I think 90% of your data is going to the cloud, coming back, and these companies are benefiting from them.
Interesting. Let's get back to you. So I think we started and then we went off on all kinds of threads, and I'm glad we did. But on a typical work day, for example, actually you said you've been at the university for 10 years.
Correct.
So explain to us how your work started and then how it's evolved over those 10 years.
So I started with the School of Computing and Information System. So I started as a part of a research center at the School of Computing and Information System, which this research is doing research in human-computer interactions. So human-computer interaction is kind of like designing ways of human to interact with computers. So the early things that you can, like Windows, for example, designing this window and how do you close the window, how to minimize it. All these ideas came out from the mouse, for example. Came out from human-computer interactions. And I started with a research center that was funded by Microsoft plus the university. It was about social natural user interfaces, like how can we make these interfaces social as well. And when I started, it was the emergence of virtual reality. Like there was the beginning of VR. Like the Oculus was introduced. There was the Microsoft Kinect, so this camera that can see in 3D.
Oh, is that
the gaming one?
Yeah, the game.
Yeah, it was. Yeah, everything started with gaming. I mean, the gamers are really on the backbone of all these revolutions that we're seeing. Definitely. So this Microsoft Kinect enabled for the first time to capture data in 3D. So it's not just a camera that you see an image in 2D, but it will tell you how far is the person is, and also it really models the human body into skeletons, and then you can track its movement. For example, you got a joint and you track its movement. This really opened up a lot of areas like physiotherapy, benefit from it, like fitness and stuff like that. So, and then came the VR, and this is where I started working with this research group. I was supporting them in a software engineering, building software to support their research. And also, we did one project with the orangutans in the Melbourne Zoo. So we also introduced a human-computer interaction, animal-computer interactions. So there was like in the Melbourne Zoo was collaboration. They came to us. They wanted to build video games for orangutans. And
for the orangutans to play.
Correct. Yeah.
Oh wow.
So there's this orangutans. I think the Melbourne Zoo has 4 or 5 orangutans, and so orangutans are very smart animals. They're really, really smart. I was shocked by like they can use tools. They can use they're social as well. So there's this program in the Melbourne Zoo is the enrichment of the animals. So because these animals are in the zoo, they're not in the wild. They always have to really introduce new things to them. Otherwise, they get bored and they get irritated.
Oh, it's like trying to raise a kid.
Definitely, it's very hard. Definitely. So and then they ran out of ideas of how to make these orangutans not bored. They've got some games, and they try to give them an iPad to play with, but they break it because one orangutan, I think, has the strength of 4 or 5 men. Oh my God. Yeah, very, very strong.
So they gave him a device.
Yeah, they gave him an iPad. They just break it. So they came to us, and then there was this. This is the first project I worked on when I joined the university. The idea that we proposed is that we project a game into their enclosure, and I could use the 3D cameras to track their hands and turn this projection into touch screen. So then this projection it's not going to break. It's just projection, right? So what I did, I developed this touchless or screenless touch service from the Connect, and also developed few games for them. So, and we did a trial, and it's still running at the moment in Melbourne Zoo, but I'm not sure it's currently running, but they're trying to do it again. So we projected the games onto the floor. So because the enclosure is a glass, right?
Yep.
So put a projected in a picture, and then a game. So I made few games for them. So one game is like very simple. I mean, we designed the game in collaboration with the zookeepers. So the zookeepers of the orangutans, they know these orangutans, what they like, what they don't like. And then some of the simple games is like a red dot. When they touch it, it explodes and they get happy. And I remember there's 4 orangutans. There's the father and the mother, the daughter and the son. So the daughter is the youngest one.
Okay.
And she was extremely excited with this game. So whenever we put it, it comes and she touch it. Like, I'm not sure. She or it, the orangutan, I mean. So, and also the other games we made is a photo gallery of their zookeepers. And they interact with it. They
like swipe through it or something.
No, we were surprised that they tried and kissed them.
Oh, wow.
They really
like them.
They really like them, definitely. So yeah, I mean, this kind of a new. I mean, we introduced some kind of new thing in the zoo industry is like digital enrichment. Previously, there was like physical enrichment. Now they call it digital enrichment. Definitely, whenever they play, they follow up with a meal. So it's kind of like a come and play, and then you get a meal. And then this is encouraging them, a reward system, encourage them to play. So I went to the zoo project.
That's fine.
Yeah. So yeah, I spent 5 years with this research group, and then after that I joined in 2019. I joined my current team at the Chancellery. It was at the beginning of I was from the first few people who was hired in the team. Okay. So there was this initiative called Better Skill Campus at the university, where they had money to uplift the infrastructure here. So here at the University of Melbourne, we have computing services similar to AWS, but it's local on premise.
Yeah, I remember the internet server was always pretty good.
Yeah, it's not only internet. We've got GPUs. We can train our models. Yeah, we've got really good GPUs. But we don't do AWS or Azure. We do local ones. They're all in Parkville here on premise.
Who manages those?
There's a department at the university called Research Data or RCS, Research Computing Services.
Oh yeah.
There's a whole team that they purchase these GPUs, they install them, they manage them as well. We work closely with them as well. And the university is investing in infrastructure, and also they wanted to invest in work in human as well. So they started this team, which they call the Melbourne Data Analytics Platform, which I started with, and the idea is that the university is spending so much money on this infrastructure, and there's these researchers, they should use this infrastructure, but they don't have the skills. Or they know how to use it, and there's someone in the middle need to help them, and that's us, the Melbourne Data and Nats platform. We know the infrastructure, we know how to use it. We also can communicate with researchers very well.
Yep.
And then we are the linkage. We're bridging them.
So do you also help upskill, or do you mainly build tools for them?
No, we only upskill. So building the tools is a task of the services, they're managing these ones.
Yep.
But we upskill them how to use these tools. We tell them how to use these tools. We tell them how to install, for example, a TensorFlow or PyTorch on this new infrastructure.
Okay.
How we teach them how to train a model on this infrastructure, because this infrastructure is not AWS. It's specialized and custom.
Yeah.
It's called Spartan, and it uses some kind of queuing system that we're familiar with.
Yep.
But these researchers really come to us to help them So the idea for us is to work with the researcher for 6 months, and then they should be able to work by themselves after that.
Okay.
So
So they come to you for like pretty much a 6-month course, and then they pretty well know almost everything they need to know.
yeah, it's not a course, it's like working with us.
Yeah.
So we work with them, which is the best way to learn.
You join their project.
Yes, we join their project. I think the best way to learn is by doing.
I agree.
Yeah.
I agree. That's how I learned my programming as well.
Yeah.
All right. So you've been doing that. Is that what you're currently still doing?
Yes, I'm currently with the Melbourne Data Analysis Platform, although I'm seconded to the School of Information Technology at the moment as well. And I'm starting to work on areas like AI autonomy and robustness as well. There's this new field as well in AI called AI robustness.
Mm-hmm.
There's this deep neural network that we've discussed. If they found out that they're really vulnerable to attacks. What I mean to attacks is that if you got, let's say I've got a model that would recognize faces.
Mm-hmm.
Okay. What they found out is that if, for example, I wear a T-shirt with a particular patterns, okay,
Yeah.
and then I pass through this image of me wearing these shirts of patterns, the model that will identify my face will get confused because of the T-shirt, because of the pixels that really this pattern of color.
Throw off the model.
Yeah, it will throw off the model. This is what they call it adversarial attacks.
Ah.
So there are people really trying to find out these patterns that will fail these models, for example, and there are ways to find them, but you need training as well. They're kind of a random noise, but this random noise, when it presents an image, it will fail the model.
Yeah.
And even worse, there are some random noise that not only fail the model, but make the model predict something else that you want. For example, I can find a noise, print it on a T-shirt, and wear it, and go into security, for example. But I know that noise that I'm wearing would identify my face as Rashid, not me, not as me. So I directed this noise to fool the model,
Yeah.
to identify me as Rashid, for example. And that's really concerning.
Commit crimes in someone else's name.
Definitely. And that's really concerning, but this is a really active research area, is that we want to find, what we call is we find defense policies or defense strategies. Is how can we pick up these adversarial attacks, and that people are trying to fool this system. And these systems are already deployed in securities and stuff. But finding this particular noise is not an easy task, but it's possible. That's what they found out by accident. And even the AI is impressive, is extremely vulnerable to attack.
Yeah, of course. And this is a form of penetration testing.
Definitely. Correct. Yes, it is a penetration test.
Yeah.
You're right.
Yeah,
For AI, yeah.
Yeah, for an AI. That's the new version of identity fraud.
Definitely, yeah.
Oh my God.
Even worse, like for these autonomous cars. So people what would they do if you go at the street, there's a stop sign, right? People would find, let's say, a speed limit. People would find patterns where they can print it and stick it on the speed limit, like small noise.
Yeah.
And it makes this car identify speed limit instead of 40 kilometers is 80 kilometers, for example. And that really messes up the autonomous vehicle industry. Or make the car identify stop sign as a giveaway sign, for example. And that's extremely concerning for a lot of reasons, definitely. And this is really a very active research area that the AI researchers are trying to find defenses to prevent this kind of attacks on that.
Okay, but in that case, wouldn't you need access to the models themselves?
Definitely. So there there are different kind of attacks. The attacks for when you have access to the model and the parameters. You can design attacks.
Yep.
There are some attacks as well when you they call it the white box, and there's this the gray box where you don't have access to the model parameters, but you have access to, for example, the output.
Okay.
This is the gray box, and there's the black box where you don't have access, you don't know anything about the model, but you make assumptions.
Yeah.
Because if you're in the area of AI, most of these models are pre-trained models, like that you can find on the internet, for example. You can assume that this model is pre-trained on some kind that, and they can definitely, it's harder to design adversarial attacks in the black box models, but most of these models are already open source, and people can get them from the internet, and they have white box at the moment, and they can design attacks. Yeah.
Okay. All right. That's very interesting, actually. But I do want to ask, what does the future hold for you, Zaher?
Yeah. So the future for me, I'm gonna stay working at the university for the time being. I'm very interested in researching the areas of AI, particularly robustness and the adversarial attacks stuff, and interested in the knowledge distillation part, where can we compress these large models into smaller models and put them on the edge, and because I think this is where the AI should this is where we should push the AI to go, to prevent these big companies so we don't repeat past mistakes. Because when the social media wave started, nobody cared. Oh, I've got a Facebook and Google for free, but we didn't know that they were collecting information about us. Now Google might know about myself more I know about myself, for example, or they know more what the government know, for example, and that's very concerning. So this kind of directions that I think the AI should go, and we might help make it possible as well.
Interesting. All right. I think a good place to finish up is you've got a very interesting YouTube page. I had a look.
Yes.
Tell us a little bit about it.
That's a project, personal project that I'm making. So what I did is I found out there's this new concept in AI that's coming out in the last 5 years. There is not much material on the internet in the Arabic language that explains it. What I decided is I make a new YouTube channel for myself, trying to explain these complex models and ideas to the youth and the Arabic language speaking, because there's no place that explains it very well. There are some people attempt to explain, but it's not. They don't go into detail. And I try to go into detail. I try to make it as simple as, and I named my page as Awraq Almiya, meaning scientific papers. And I try to take one paper, explain it bit by bit, simplify it. Usually I try to choose very complex papers, like there's this paper Transformer, for example, that was introduced in 2007, which is really the backbone of ChatGPT and all these large language models. So I think it's very important for our people to understand these concepts technically. So we really, for our community, we have to participate in this revolution, I guess. We shouldn't really set aside and see other people leading the way. And I think participation in this kind of stuff, we do need to understand what's happening. We need to study it, and the channel is a way of also giving back to the community for in this area as well.
Yeah, it's really great. Like I think you explored the Bitcoin white paper in there.
Definitely, yeah. I did as well. Yeah. The Bitcoin. I really love reading papers. And the other way is the other goal for me is the best way to understand things a thing or an algorithm or a scientific paper is try to teach it.
Teach it, yeah.
When you try to teach a thing, you will really understand it. And this is two-way benefits for me as well. I'm benefiting from making these videos because I'm teaching myself as well. And when you try to learn something and you're in mind that you want to explain it very well and in the simple terms, this is when you really get the essence of the thing that you're trying to. So I wanted to learn Bitcoin, for example, and I went to the white paper and I wanted to learn it very well. So I had in mind, okay, I want to make a video to explain it. And the way and that's why I was able to understand how Bitcoin works.
Okay. I mean, I don't want to open up like a whole new topic. I know we're supposed to be focused on AI here.
Yeah.
But in as short amount of time as possible, what do you think of Bitcoin and its use cases?
I think Bitcoin is an extremely smart idea.
Yeah.
So I don't know who Satoshi Nakamoto is, but I don't think it's a single person. I think it's a group of people. Okay. But the way they introduce blockchain is physically impossible to alter.
Okay.
So they introduce a system where when you store something in it, right, it's kind of impossible to modify because they introduce this chain of blocks where every chain is very dependent on the previous one in a way that it depends on the data it's stored in. If you change something in a chain, you have to change all the previous ones. And to be able to change all the previous ones, you need extremely large, impractical computing resources. Okay. And that's the main idea. And it really goes down into one cryptography algorithm called SHA-256.
Yes.
Which in basic format it tries to encrypt any text into a fixed length of text and numbers. And that encryption of the algorithm is one-way direction. There is no way from looking at the encrypted message they'll be able to know the original message.
Okay. And
nobody was able to break this algorithm until now.
So far.
So they predict that it could. I mean, if you want to predict it by brute forcing, meaning that trying all the possible, you need millions of years using every computer on Earth at the moment, every GPU, every resources. So it's practically impossible to do that. But they say with quantum computing, they might be able to break it. But then there will be another algorithm. They will introduce another algorithm that is also impossible to predict.
So could they just replace the SHA-256 with a more updated encryption?
They could, yes, in the future, I think. But at the moment, they rely on SHA-256, which is hasn't been broken now. It's impossible with the current infrastructure and the computing knowledge we have. It's not possible, and it's partly like it's only one way, but it has a lot of logical operations. That, for example, I'll give you one example, is 10 plus 1 is 11, right? Mm. If you look at 11 by itself, and I don't tell you it was the result of 10 plus 1, would you know? You wouldn't know.
No.
There was multiple ways.
Yeah.
But every time I do 10 plus 1 is 11.
Yep.
That's one direction.
Okay.
Which is correct all the time. But when you go the other way, you can't really know. And this is really the essence of SHA-256.
Okay.
Doing this one direction is always correct, is always giving you the same number of characters and numbers. But when you try to go back, there's endless possibility. And that's why SHA-256 is very hard to break.
Yeah.
It works for one direction, but doesn't work for the other direction. It's all I gave you a very simple example to get the idea, but it's more complex than that with the SHA-256. But this is the idea of encryption in Bitcoin.
Interesting. And And what do you think some of the practical use cases of Bitcoin will be? I know this can be a bit of a hot topic.
Yeah, this needs another podcast, I think, by itself. So I think the usage of the it's not Bitcoin is a financial system, right? It's a currency, but I think what's really important is the blockchain.
So the technology
underlying the Bitcoin.
Yeah,
that's what the really big benefit there, and it could be used in multiple ways. Like it could be used to, I think now Sam Altman has started a new company called WorldCoin.
WorldCoin.
Yes, where he's introducing the way of, so because it's blockchain, when you put something on it, you can't really modify it. So what he said, okay, let's make digital IDs. Identifications. So I think in the WorldCoin app, he's proposing that you register with the app and you go to a location with a camera and it takes your biometrics and creates a digital print for you, put it on a blockchain, and this is your ID. Nobody can change it. Nobody can really take your identity.
Okay.
But I know it's a dystopian idea. I know, no, but this is
he's trying.
He's trying, and if he succeeds, it might really replace IDs. You might really need to have an ID that's on a blockchain, because that's how the society works, for example, in the future. Because if you have your ID stored on a blockchain, nobody can use it. Nobody can really modify it to say, oh, this person is not that person.
So it kind of, well, in a sense, gets rid of identity fraud.
Sorry?
It gets rid of identity fraud in a sense.
Yes, it prevents identity fraud completely.
Yeah.
But then, I mean, if you look at this, like all blockchains, and the main idea of Bitcoin was to make it decentralized.
Yes.
Is to break out from this organization, the banks, the central banks. But if you look at the implementation that we have, like Ethereum or others, they're not decentralized. So they're they're running through companies, and they're storing your private key. You shouldn't really store your private key with these companies. You should have your own wallet if you're buying Bitcoin.
Yeah.
But people are not really educated enough to know this stuff. So there are this company like what's called Coinbase, for example.
Yeah, Coinbase.
Yeah, all these companies, what they do is they have this infrastructure to store your private key and enable you to make transactions.
Yeah,
but they're transactions. So, but they control everything. It's not centralized. It's not decentralized. It's centralized.
They don't claim to be.
So the pure idea of Bitcoin, I don't think it exists anymore. This big organization hijacked it, and unless you are participating in Bitcoin and you have your own wallet on your computer, your private key is in your computer, in your phone, and it's not on the internet. Yes, but most people, they don't. They have sign up an account and some of these companies, and then I see my Bitcoin there. But that's if your private
the idea behind it.
Yeah, if your private key is not with you, you don't own it. Private key shouldn't be shared. Yeah.
Yeah. I think the problem comes down to access, because ultimately, like that, the only reason, for example, crypto became mainstream because more people got access to it. And most people aren't going to go down the route of, having a hardware wallet, where they put their key. There's the story of the guy who lost his hard drive and then knows how much Bitcoin went with it as well.
Yeah, 6 million.
Yeah, if not more. So I think that's the problem. But the idea of Bitcoin itself, to me, sounds like it could be like the infrastructure for a financial system. So people could build on top of it, essentially.
Yes, definitely. I think if it's to be implemented the same way that was introduced in the paper, like fully decentralized, is a great idea. I mean, you could, this is the idea of Web 3.0, is trying to use blockchain as the backbone of the internet instead of...
So that's the idea of Web 3.0? Because it's been very bastardized since.
Yeah, but I'm not sure if it's gonna I'm sure some organization will hijack the ideas and benefit from it.
Yeah.
But the pure idea is trying to we break out of this centralized internet where internet is controlled by Amazon or Facebook or Google, like through
the data centers. Yeah.
Definitely, yes. But yeah, that's the idea. But I mean, that's for another topic.
Yeah, I think this one needs another podcast. We're going to bring you back.
And
when we'll discuss, Bitcoin and blockchain and decentralization, decentralized systems.
Definitely, yeah.
I think it'd be a very interesting conversation, and it's something like the world is going through, like with CBDCs, central bank digital currencies.
Yes.
And before I go any further, because I can geek out on that, I'd just like to thank you for coming on the podcast. Before we wrap up, just tell people where they can find you on social media and on the internet.
Yeah, thank you very much for having me in this great podcast, and I really encourage everyone to join the Muslim in Tech, which is a great initiative, and you should find information of how to join the Slack channel. So yeah, you can find me on Twitter at ZJOUKHADAR. And from there, you can find out my other pages as well.
Very nice. Thank you, Zaher. And just because you mentioned, the Muslims in Tech Slack group and our private network, so essentially we'll put links to all our social media, so whether it's LinkedIn, Twitter, Instagram, in the description below, so you can check out our stuff. And also to become a member of Muslims in Tech, we operate on a referral system, so you get referred by someone that's already a member. We operate currently in Melbourne, Sydney, Queensland, and Toronto, Ontario in Canada. And inshallah, we're looking to come to a city near you soon. But of course, there's only so many of us, so we have to do it slowly. And as we build out this infrastructure, we plan on bringing more of you on board. Thank you all for tuning in, and Assalamu alaikum wa rahmatullahi wa barakatuh.
Assalamu alaikum.